going to have in the denominator not just a square root of a number, but we're going to have what we call a complex number, or, well, not a complex number, but we'll have a number plus a square root. So what we're going to end up doing is we're not going to multiply by the denominator, we're going to multiply by the conjugate. Now, if our number is in the form a plus square root b, the conjugate is a minus square root b. So the only thing that changes is the sign. You just use the opposite sign. And it's going to make life really nice and easy for us in when we do it. So that's the definition of conjugate. Now, how do we simplify or rationalize using the conjugate? Same steps. We multiply the numerator and the denominator by the conjugate. We multiply it all out using FOIL or the box method, whichever you prefer, and then we simplify. All right, so let's do a couple examples of this. Example number 8. So for this problem, we have 7 over 3 plus the square root of 5, and we need to get that square root out of the denominator. So what we need to do is we multiply the whole thing by the conjugate. What would the conjugate of this denominator be? 3 minus square root 5. Okay?
Wouldn't that make the bottom one just 1?
It wouldn't make it 1. Okay, I'm going to put it all in parentheses. Okay? And then how are we going to multiply that numerator? What property are we going to use? Distributive. So we're going to distribute the 7. So 7 times 3 gives me 21 minus 7 root 5. And then we FOIL the bottom. So let's do 3 times 3 gives me 9. 3 times negative square root 5 is minus 3 square root 5. 3 times negative square root 5. Okay. Positive square root 5 times positive 3 gives me plus 3 square root 5. And then positive square root 5 times negative square root 5. Negative 5. Remember, multiplying a square root by itself, those square roots cancel.
You just FOILed the bottom?
We just FOILed the bottom. And then let's simplify this. 21 minus 7 square root 5. And then we have negative 3 root 5 plus 3 root 5. What happens there? They cancel. So what's left in the denominator? 9 minus 5, which is 4.
Can't cancel it.
Does anything simplify here? Nope. So we are done. So multiplying by the conjugate gets rid of that middle term when we FOIL it out. Okay, example 8 or 9. Square root of 3 over 9 minus square root 2. Now we have a square root in the bottom, so we want to multiply by the conjugate. What would the conjugate be? 9 plus square root 2. Good. If you don't do that, it won't work. We multiply by the conjugate because did you notice how in the last example, after we FOILed it all out, that middle term all canceled? That's why we do it. Okay, so I put parentheses around it. We just distribute that numerator, right? So the numerator would be 9 square root 3 plus 3 times, or square root 3 times square root 2, square root of 6. We can multiply the insides. All over. Now we want to use the box on this one because I was asked to. Either method will work, so it doesn't matter. So I'm going to use the box to multiply the denominator. 9 minus square root 2 and 9 plus square root 2. Okay, 9 times 9 gives me 81. 9 times negative square root 2? Negative 9.
Negative 9
Square root 2. Positive square root 2 times 9. Positive 9 root 2. And square root of 2 times negative square root 2. Negative 2. So it's just, these square roots are just kind of act like terms, you guys. So these two are considered, I guess, what we could call like terms. So what would 9 square root 2 minus 9 square root 2 be?
Nothing.
Nothing. They cancel. So what is left in the denominator?
79.
81 minus 2, which is 79. So we get 9 square root 3 plus square root 6 all over 79. Now, does anything reduce here?
No.
No. So this is our answer.
Wait, can you multiply the square root by square root?
These are being added, not multiplied. And since the numbers on the inside aren't the same, we can't add them. Okay, really quick, guys, hold on.